Hello and welcome. This is our demonstration for our web page for the Orbital Horizon, our project for hunting exoplanets using AI. So, first thing we'll see upon opening the page is the Orbital Horizon logo. So, if you scroll down, you can see the planet navigators to see if which section of the website we want to go to or uh, navigate to. So for the about page, it's just below na, na, the planet navigator. So here's our project demo. Uh, these are the steps to uploading and then processing the data and then until visualization. So this is our methodology. Oh, you can see it. Yeah. And then our feature importance analysis. So here we are at the ARE workbench. So first thing we'll see is the single object prediction. So can enter parameters of a celestial object to get an instant prediction from our pre-trained model. So we can put anything here. So radius of Earth is 1. That's orbital period. Its temperature, its stellar temperature, 5778 for the star. Influx is 1 and the stellar radius is 1. So we can predict here. It says planetary candidate. So we can visualize here immediately. So we can see. So this is how this is actually the Earth's comparison with the Sun. So the Earth, and then you can also. Oh, right now it's locked since we took it from the AI workbench, but we can use this too if we want to customize our own planet. So this is the predicted objects, what do you call that, information, and then its habitability, it's potentially habitable, a rocky planet, and then its summary. All right, so we can, if you don't want to see the sun in there, and we just want to see the planet, and we can use this one. So this is the Earth, and then we can see its that's actually not the Earth, but it's just a representation of the planet we in, inputted in here. So that's just a surface we took from the internet. So uh, to represent a planet surface. So right there. So if you want to make a new planet and but you don't want to lose this planet, we can save this one, and then we can press new planet in here. So and then randomize the surface. So we can change a planet's radius, and then uh, after this we can compare it with other celestial objects. So this is the planet we simulated compared to Mars, the moon is the moon, and then Jupiter, and then Sun. So the Sun is way bigger than the Earth. So if we want to compare the predicted object, the Earth, with our custom planet, so you can see it there. So other we can also put this here, so we can see how big the planet is compared to solar the system. All right, so right there, you can change its temperature, its insolation, the lighting, and which the light gives off, the stellar object gives off, stellar radius. We can increase it too, and then the temperature as it goes hotter, the surface gets bluer. So orbital period can make it slower or faster, depends. So if you want to use this one for a better simulation like the Earth 365, and then just fast forward it so we can see it faster. The habitability is too hot, so we want to put it here so it's potentially habitable. Alright, so it became a gas giant now. So the perfect habitability is 1 to 2 times the Earth's size, and the temperature is like negative, and then it gets too cold to a positive mm, 100, maybe 100 Celsius. All right, so that's for the just for the interactive simulator. We can go back to all right, still spinning. We go back to the AI workbench to see if to see the data set to run the data set from NASA. We're gonna run the Kepler data set for this demo. All right, so we're running the prediction right now, and then it shows all the confirmed planets in here, and then we can visualize them. We'll pick a random number here, 1327. So we can see that this one is not habitable because it's too big for compared with Earth. So it's not habitable. It's an ice giant. And then we can see its parameters here. So if you want to compare this one to other planets, to Earth, for example, so it's 5 times the Earth radius. And then with the Sun, so it's way smaller than the Sun still. And then Jupiter, very close to Jupiter. And then it's so compared to Mars, and then you can see its rotation too in here. All right, so for more of it, so for those who wanna download the dataset, so you can choose the Kepler K2 or test. You just press which one you want and then download. All right, it starts downloading there. So have everything in there. And then if you wanna run your own CSV file or try the simulator by itself, the predictor. So you press the test, the one I just downloaded, upload. Alright, so for this one, it shows the pre-processing details. So missing values, there's no missing values for each of these. The temperature and radius columns, and then the engineered features in here. So if we wanna predict that with a pre-trained model from us too. So just press that one there, and then it's running the prediction, and then it shows the 124 planets found. You can choose this and visualize this too. So it's very big. It's 12 times the Earth's radius. And I think, yep. So that's most of it. If you need any if you want to ask any questions or just get random facts, here's Astra, our AI robot. Or you want to ask her what's the project about, uh, how we found the exoplanets, and then anything here. Or you can ask other questions. So if you have this this project, so we use machine learning models, so she can answer any of your questions related to the project actually. So that's most of it, and thank you for watching the video.